Hey everyone, welcome to 90 Days of DevOps Community Edition, and I'm super excited to have you for this particular session. In this particular one, we are going to learn about open standards and how they are empowering cloud native innovation. Now, this particular topic, I would say, is definitely essential if you are beginning your cloud native journey, or even if you are just in sort of a middle of your journey into the cloud native ecosystem. The concepts that are involved in this particular topic are pretty essential if you just want to know how the cloud native ecosystem works in general, right? And the most famous question that is often asked in the community, that how are there so many tools in the cloud native landscape, and how are they, communicating with each other? How are organizations able to use multiple tools for the same problem? So these are some of the questions that we are going to answer by studying this particular topic, and I hope you get some value out of this. So let's get started. Yeah, before we begin, a little bit about me. So hi again, my name is Kunal Verma, and I'm working as a DevRel at KubeSimplify, where we are simplifying the cloud native and WebAssembly ecosystem for everyone. So make sure to check us out. I'm also the maintainer for the Commercial project, which is an open source cloud agnostic resource manager, which will help you to monitor and track your cloud costs in a multi-cloud environment. It's a pretty interesting tool, so make sure to check us out. And I'm not just saying because I'm the maintainer of the project, but it can genuinely help you in your multi-cloud environment. Lastly, I am an open source and cloud native advocate. That means I really love helping people out in getting started with open source, cloud native, DevOps, and all this amazing stuff, because it's just amazing to get involved, and I hope that you agree with me here. Lastly, you can certainly reach me out on my Twitter and LinkedIn. I am pretty much active on both the platforms, and we can have a conversation there. Cool. So let's start with a very basic question, right? I really want to keep this talk pretty simple for everyone because this is kind of a beginner session, right? So let's start with a very basic question about what is an open standard, right? Let's start from here. So let's break down these two terms, and first we'll understand what is a standard, and then we'll understand what does open mean. So a standard are basically set of universally accepted protocols and formats for different services and tools, right? So these are basically the protocols and formats on the basis of which a certain tool or a certain service works. And these are universally accepted. That means that a lot of organizations out there agree upon these particular standards, right? To make their services and to make their tools. Now, what does open mean here, right? And if you haven't guessed it till now, it means open source, right? So this essentially means that any public facing community, right, the open source communities out there can participate in the development, maintenance, and any future changes to these particular standards. So open standards are essentially set of protocols and formats for the tools and services, and these are agreed upon by a lot of organizations out there in order to make their tools. And these particular organizations are also included in the development, maintenance, and any future changes to these particular standards, right? So I hope you got the general idea of what is an open standard. Now, we understood what is open standard, right? The question is, why do we need them, right? What is the need of these particular standards? And to be honest, you've got to wait till the end of this particular session to know the reason for that, because as we'll go through this journey together, you'll definitely be able to understand. You'll eventually get the answer to this particular question, why do we actually need them, right? And I really hope you stay till the end. Cool. So let's start with a story, right? Let's go back in time and understand how everything got started into the cloud native ecosystem. So it all started with Docker, right? And everything that we know about containers and sort of the revolution in the cloud native ecosystem started with Docker. So let's see what Docker brought with itself. So we all know that Docker was launched in 2013, and it quickly became the de facto technology when it came to running containers, right? Now, one thing to note here is that containers existed previously as well, right? Before even Docker was launched. But what exactly Docker did was it brought numerous benefits to the ecosystem, right? And some of which are listed here. One was portability of the containers, and the other was a rapid deployment and scaling of the containerized applications. So these are some of the features that Docker brought with itself, and that's how we sort of revolutionized the entire process of working with containers. Now, these are some of the statistics of how Docker was adopted from the year it was launched. So this is provided by Datadog. And as you can see from this, that we can see a massive growth of Docker being adopted into the companies, right? Every organization out there who wanted to work with containers had adopted Docker as their primary tool, right? So that's how everything got started. Now, as we saw that Docker was launched and it quickly became one of the de facto container technologies out there, but something very interesting happened. We saw a rise of a very diverse container ecosystem, right? So the story continues, and this is not the end right now. So what essentially happened was that Docker actually paved the way for containers. And it actually paved the way for other organizations to work on different tools covering different aspects of a container, right? So we saw a rise of a very diverse container ecosystem where a lot of organizations were working to develop their different container technology. So essentially, Docker paved the way for containers, right? Docker was the very first one, but it had some limitations as well. When we are talking about the early days of Docker, right? So Docker had some limitations when it came to the security aspect of its containers. Now, a solution for that was Rocket. So Rocket, which was a container technology launched by Core OS in 2014, was an answer to those limitations that were faced by Docker. So my point here is that the journey got started with Docker. The majority part we know about containers started with Docker, but then we saw a rise in container technologies as the demand of containers increases, right? As more and more companies started to adopt the container technology. So essentially, we can say that containers everywhere. So everyone was talking about containers and everyone wanted to use containers in their organization. So as I previously mentioned, right, that everything started from Docker, but soon we realized that Docker isn't enough. And we actually need to find a way for companies to make more and more container tools, right? So the question is, what was the need of the hour, right? So the need of the hour was a standard, right? An open standard to pave the way for new container technologies to be developed in the future. So the main aim was to set these standards and protocols for organizations to be able to build new container technologies, right? And that's how the ecosystem would grow, right? That's what we needed. And here we come to our very first open standard in the list, which is called as Open Container Initiative, or OCI. So this is the very first open standard which was developed. And let us quickly have a look at what are some of the things that OCI actually specified. So if you look at the definition of OCI, this is directly, by the way, from the documentation. So the Open Container Initiative is an open governance structure for the express purpose of creating open industry standards around container formats and runtime. So the important thing to note here is that the OCI actually specified the open industry standards for container formats and container runtimes, right? And that is what we needed. That was the need of the hour. So the OCI was actually created in June 2015 by leading container organizations of that particular time, which was Docker Inc., Core OS, and many more. And the main aim was container globalization. How can we set the right path? How can we set these standards and the formats for other container technologies to be developed, right? And how can we promote container globalization in general, right? That was the main aim of developing OCI. So let us have a look at some of the core principles of OCI, right? On which OCI was actually built. The number one is composability. So composability essentially means that every container is independent from each other, right? Every container will run independently from each other, but will be secure and portable at the same time, right? And that is what composability actually means. The next one is decentralization. And what it defines is that every container, despite the environment it runs in, it will run the same, right? So we all know about the OS independency of a container, right? Every container runs the same despite of the operating system you're running that into, right? So that is how the OS independency of a particular container came into being, because of OCI. The last is minimalism, and this means that every container will run a simple process when it's started in your particular operating system. A very good example of this, you can see over here, that if you want to run an nginx container, you just simply type docker run -d nginx and you will have an nginx container up and running. So that is what minimalism meant, right? Make it absolutely simple for running a container, right? That is what minimalism meant. So these are some of the core principles upon which OCI was actually built. And as you can see, everything that we know about containers, right, the basic concepts sort of started from the OCI, right? So this is where everything came from. Now, when we're talking about OCI, right, so OCI basically gave us some specifications, right? So the specifications are nothing but the actual protocols and the rules that are written for different aspects of the container, right? And when we're talking about OCI, it's pretty important to know these as well. So let us have a look one by one. The number one is the image specification. Now here we are talking about how a file system bundle should be packed into an OCI image, right? Here we are talking about how a container image will be made. So all the rules and the protocols related to making a container image are described under the image specification. Now, what is the use case of the image specification, right? Why do we need image spec? So the formats and the rules which are defined under the image spec will help us to create tools for building, transporting, and preparing an image to run. So basically the image spec defines all the rules and all the protocols that we need in order to create tools for building, transporting, and preparing an image to run, right? And that is what the image specification actually defines. How a file system bundle, how can we take our application code and package it into an image, which is essentially called as an OCI image because it's adhering to the OCI specifications, right? So that is what an image specification defines. And here are some of the tools that actually help us to make these OCI images. So we have Docker, Build Kit, and Podman. There are a lot of tools out there, but I have just listed a few of them which are very popular in the ecosystem. Now the next spec is the runtime spec, right? So essentially we have built an image and now we want to run it. So the runtime specification defines how to run the file system bundle, how to actually run the OCI image that we made in the first part with an OCI compliant runtime, right? A container runtime which actually complies with these certain rules and the formats which are specified under the runtime specification, right? So that is what the runtime spec actually defines. So the runtime spec actually specifies the configuration, the execution environment of a running container, and the lifecycle of an entire container at runtime. So every aspect of a container when it's running is specified under the runtime specification. One very interesting thing to note here is that, as I previously mentioned, that OCI was created by leading container technologies at that particular time, which was Docker, Inc., and CoreOS, and many more which were out there. So the container runtime which is used by Docker is called as runc, right? And that is what actually runs the container. Docker is a complete container engine, right? And what actually runs the container is runc, which is the container runtime of Docker. Now at that particular time when OCI was created, Docker actually donated runc as a reference implementation to create the runtime specification. So the runtime specification that we know today, it started from runc, right? It has been referenced from how the runc actually worked, which is pretty interesting. And you can definitely see from here that what impact Docker had actually created in the entire ecosystem. Now these are some of the tools right now that are using the runtime spec. So we have Kata containers, Containerd, a very famous container runtime that is being currently used in the ecosystem. And we also have gvisor. So these are some of the tools that are adhering to the runtime spec. So what have we covered till now? We covered how to make an image, right? We covered how we can run that particular image. Now what's left? The last is the distribution spec. And that is how we see how we can distribute that image, right? So if you see, we are actually going in order, right? We created an image, we ran that particular image, and now we are concerned with how we can distribute that image. So the distribution specification actually standardizes the API for image distribution, right? And it is basically based on the Docker registry HTTP API version 2 protocol. That is essentially Docker Hub. Again, the reference implementation of the distribution spec was given by Docker, that is Docker registry or Docker Hub. And these are some of the tools that are being used in the industry which adheres to the distribution spec. We have Docker Hub, we have GCR, Google Container Registry, we have ECR, the Elastic Container Registry by AWS, and all the current container registries which are being used by organizations all adhere to the distribution spec, right? So these are essentially the OCI specifications, or what are the actual protocols and rules OCI defined for us. And I hope that you can see the impact of these particular rules and standards being created, right? So these were pretty essential at that particular time. Okay, so now we talked about how the OCI specification actually came into being and how it helped the overall goal of container globalization, right? And I hope that you could actually see what the impact of setting these particular formats and the rules had been to the organizations at that particular time, right? And the OCI specifications are being followed till date. Now, we talked about containers, right? Now let's talk about phase 2. Right? What happened after container globalization? The OCI specification actually helped organizations to build new container technologies, right? But now we are talking about what happened beyond that, right? What happened after container globalization? What was the next big revolution in the cloud native ecosystem? Now, can you guess it? right? Can you take a moment, take a pause here? You can pause this particular session and maybe take a guess what actually happened, right? What was the second revolution sort of in the cloud native ecosystem? Now, you may or may not have guessed, but if you guessed it, congratulations, it is container orchestration, right? And when we are talking about container orchestration, how can we not talk about Kubernetes, right? So we welcome Kubernetes to the picture, and here we are talking about running multiple containers, right? We talked about running single containers, we talked about running 2 or 3 containers, but what happens when we run hundreds of containers, right? And that is where the concept of container orchestration came. And when we're talking about container orchestration, Kubernetes is one of the center point for that particular topic. So let us quickly have a look at how Kubernetes got evolved and what impact it brought to the ecosystem. So this is the exact line quoted by the creators of Kubernetes, right? We have Brendan, Craig, and Joe Beda. Everything we know about cloud native ecosystem started from here, right? So a huge shout out to them. So what they said was, while Docker was great at building and packaging individual containers and running them on individual machines, there was a clear need for an orchestrator that could deploy and manage a large number of containers. And here we are talking about thousands of containers across a fleet of machines, right? Now here we are talking about not running individual containers, thousands and thousands of containers across a fleet of machines, right? Not even a single machine. So that was the initial problem statement upon which Kubernetes was built. So the version 1.0 of Kubernetes was launched in 2015, and initially it was actually called as Borg. Again, the goal was to run multi-containerized workloads or applications across multiple machines. That was actually the initial goal of running Kubernetes. Kubernetes is a lot more than a container orchestration right now, but when it initially got started, that was the main problem it was solving for us. Now, as Kubernetes was launched, right, it quickly became the center point for companies when it came to working with containers, right? Because this was the actual solution the companies were looking, right? How can we run multiple containers very efficiently? And Kubernetes was actually solving this very problem. As Kubernetes gained popularity, right, and a lot of companies tried to adopt Kubernetes, we also know that Kubernetes was eventually accepted as a CNCF project, right? So it came under this Cloud Native Computing Foundation hood, and a lot of companies out there set on a particular task of extending the functionality of Kubernetes for many diverse cases, right? Many diverse use cases. So that was actually the aim of a lot of organizations out there, because as I mentioned, Kubernetes had become a center point for companies when it came to working with containers. So a lot of organizations set on a mission of how we can extend the functionalities of Kubernetes. And that's how the CNCF landscape came into being. Now, these are some of the current stats of a very recent report by CNCF, so you can definitely check out the numbers of this massive project, right? I mean, these numbers definitely do justice because Kubernetes, as we know, is one of the largest open source projects in the world. So we can definitely see that through these numbers as well. But essentially, my point is that Kubernetes was at the center of the CNCF landscape, and the CNCF landscape, the overwhelming CNCF landscape that we know right now, everything started from Kubernetes, right? So all of the tools that we see in the landscape here, the main aim of every tool was to extend the functionality of Kubernetes for different and diverse use cases, right? And that's how everything got started. So to answer your question, how are there so many different tools in the CNCF landscape? There is your answer right here. Everything started from Kubernetes, and all the organizations wanted to extend its functionality, right? So essentially, when it got started, Kubernetes was at the center of the CNCF landscape, and now we all know how diverse the landscape has become, right? Cool. So now we all agree that Kubernetes was great, right? But there were some challenges with Kubernetes as well. So this is a very simple image of a node, right? And where we have a kubelet and we have the container runtime component. Now, when we are talking about initially, right, we are talking about the initial stages of Kubernetes. The two leading container technologies which were in the ecosystem, one was Docker and the other was Rocket. So initially, Kubernetes only supported these two container technologies as a container runtime, right? As a way for containers to run inside their pods. Now, this particular restriction at that particular time posed a few challenges. Let's have a look at them. Now, as I mentioned, the two container technologies that Kubernetes supported was Docker and Rocket. So the logic of these particular tools was very deeply ingrained with the Kubernetes source code, and specifically the kubelet. And this particular restriction posed a few challenges. The number one was low rate of new feature development. Now, as I mentioned, the logic of these particular tools were very deeply ingrained into the Kubernetes source code. So whenever it came to integrating new features of these particular tools into Kubernetes, it was a very long process, right? Because we all know how long a Kubernetes release process can be. And that is where we actually saw a very low rate of new features being developed for these particular container technologies, right? And in general for Kubernetes as well. Now, as I previously mentioned, right, that we saw a rise in the container technologies, and now that we have Kubernetes, every container runtime out there would want to integrate with Kubernetes, right? They would want that their container runtime is compliant with Kubernetes. Now, as the logic of a container runtime was very deeply ingrained into the Kubernetes source code, so the developer or the team who are working to create a new container runtime would need a very in-depth knowledge of the Kubernetes source code itself, right? And this is something that I'm sure you can definitely see how this particular thing posed a challenge, because now you would have to spend extra time learning about the Kubernetes source code rather than developing your container runtime. And these were some of the main challenges and limitations which actually posed as a roadblock for all the organizations out there who wished to integrate their container runtimes into Kubernetes. So what was the solution here, right? How can we solve this particular challenge? Now, I'm not sure if you can guess it already, but there was a need of a standard again, right? There was actually a need of the set of protocols and formats which are agreed upon by all these organizations so that they can easily create container runtimes which can be integrated into Kubernetes. And that is where we come to the second open standard in our particular list, which is container runtime interface. Now, if you're watching this particular session and if you have heard of container runtime interface before, let me know in the comment section down below, right? So this is the second open standard in our particular list. So if you look at the definition of CRI, again, this is from the documentation itself. So the CRI is a plugin interface which enables Kubelet to use a wide variety of container runtimes without having the need to recompile the cluster components, right? So essentially, CRI defines an interface. It basically defines an extra layer through which we can integrate different container runtimes out there, right? And that is what CRI basically defined. So the CRI basically came out with the Kubernetes 1.5 release. You can definitely check out the release docs to learn more about it. But essentially, these are some of the internal components that are defined in the container runtime interface, which is protocol buffers, gRPC API, and certain libraries, right? Now, I'm not going into the depth of these because this is a beginner-friendly session, but essentially the CRI defined the main protocol for the communication between the kubelet and the container runtime. And the protocol which is being followed is the gRPC protocol. Now, if you want to learn more about these internal concepts, I will certainly link some of the resources at the end of this talk, so you can definitely check it out. And this is basically the GitHub repo of CRI API. This is under the Kubernetes organization. So you can see, right, that the CRI API is open source and you can contribute to it. Now, we saw the architecture of Kubernetes previously, right? And we saw how it looked, how it was restricted to just using Docker and Rocket as a container runtime. So this is sort of how things are working currently, right? This is a very bird's eye view of how things are working, but essentially we have a CRI plugin, which is in the middle of the kubelet and the container runtime component. And that's how we are able to communicate with multiple container runtimes, right? Now, one important thing to note here is that all these container runtimes are OCI compliant, right? So they are following the runtime specification, which we learned previously. Yep, I think you can definitely see the impact of how the CRI plugin changed the entire story of Kubernetes and how it actually enabled organizations to easily integrate their container runtimes and use it with Kubernetes, right? So this is pretty interesting. Now, when we talk about running containers, right? Because Kubernetes essentially runs containers only, right, inside a pod. We talked about one aspect of a container, which is container runtime, the component which actually runs the container. Now, there are two more aspects of a container, which is the storage aspect and the networking aspect. And a lot of organizations were actually building those particular tools as well, right? The networking and the storage solutions. Also, apart from the containers, there were many use cases of Kubernetes that needed multiple tools to be used, right? Because Kubernetes had a very diverse use case. So after the launch of the container runtime interface, the community actually thought that why stop here? Why should we create just one open standard? Why can't we create sort of an ecosystem of multiple open standards that can help to grow the diverse use cases of Kubernetes, right? So that is what the community thought. And now this is a very interesting part. So we talked about there are different functionalities in Kubernetes, right? And that sort of paved the way for new open standards to be created. So let's discuss each one of them one by one. The number one is the CNI, which is the container network interface. And this basically defines the protocols and rules of how the containers can communicate with each other, right? So we talked about CRI, which is the runtime interface, which defines how we can use multiple container runtimes with our Kubernetes cluster, right? The CNI defines how we can use different networking solutions with our Kubernetes cluster. And here are some of the tools, very famous tools that are being used currently in the ecosystem: Cilium, Flannel, and ViewNet. If you have worked with Kubernetes, you would have definitely worked with these tools before. Now we talked about the network aspect. What's next? Next is the CSI, which is the container storage interface. And here we are concerned with how can we use multiple storage solutions which are out there. And these are some of the storage solutions that are available for us to use with our Kubernetes cluster. So we have OpenEBS, Longhorn, Custom VM. And by the way, the tools which I have listed right here are not just limited to only these. You can definitely check out more tools from the entire ecosystem in the CNCF landscape also. Now we talked about the container aspect. We talked about the CRI for the runtime aspect. We talked about the CNI, which will take care of the networking aspect. And then we took a look at CSI, which is the storage aspect. Now, what about managing traffic, right? Managing the load to your Kubernetes cluster. So there were a lot of organizations that were building the solutions, and that particular category, as we know, is called as service mesh, right? So a lot of organizations were actually building these tools. And again, we needed some kind of an interface for these organizations to be able to integrate the tools easily with Kubernetes, right? And that is when we come to the next open standard, which is service mesh interface. And that is how it enabled multiple service mesh technologies to be used with Kubernetes, right? And these are some of the examples from across the ecosystem. So we have HashiCorp Console, we have Linkerd, and we also have Istio. And if you have been involved in the cloud native ecosystem, you would have definitely heard of these particular names. And the last but not the least in the list is the CPI, which is the cloud provider interface. And that is how we are able to use Kubernetes on cloud platforms, right? So the very famous tools out there, we have Azure Kubernetes Service, we have EKS by AWS, we have the GKE by Google, the Google Cloud Engine. So the cloud provider interface basically defines the rules and the formats which are used by these particular organizations to run Kubernetes on cloud, right? And that's how you are able to run Kubernetes on cloud, right? So these are some of the open standards that are out there and that exist in the ecosystem right now. And you can definitely see the amount of impact that these standards have on extending the different functionalities of Kubernetes, right? So the goal over here was same, right? How can we extend the functionalities of Kubernetes? And that's how the community actually laid the foundation and created these open standards. Now we are essentially at the very end of this particular talk, but I just want to quickly talk about two more new ecosystems that have quickly developed and are working to create new open standards in the cloud native ecosystem. The number one is the observability space. So here we are actually talking about how we can simplify the instrumentation, lowering the data aggregation costs, and standardizing formats and frameworks to ensure visibility across the entire stack, right? And here we are talking about the observability stack. So the stack includes how can we track metrics, how can we track events, traces, logs. So in this particular space, we are basically concerned with the solutions in the observability space, right? And how they can be integrated with Kubernetes. And when we are talking about building open standards in this particular space, we cannot forget OpenTelemetry, right? So OpenTelemetry is again a CNCF project, and this basically set the foundation of building new open standards in the observability space, right? So this is the number one aspect. The next is the application deployment one, which is pretty interesting. And here we are concerned with how we can simplify the application deployment on any platform while enriching the developer experience. So in this particular space, we are talking about the solutions which are related to simplifying the deployment process of the application, right? And one of the open standards which is linked in this particular ecosystem is called OAM, or Open Application Model. Let me know in the comments if you have heard of this particular term before, but essentially OAM defines a new way, a new approach of application deployment, and it's pretty interesting. Make sure to check it out. Now, Open Application Model is the open standard, right? It's the protocol that is being followed. Now, one of the tools in the ecosystem which is actually following the Open Application Model is called as Kubella, right? Again, Kubella is a CNCF project, and it's actually following the Open Application Model to define a new way of defining the application deployment, right? So you can definitely check it out. The last tool in this particular section which I want to talk about is Crossplane, which is again defining a new framework of creating your own cloud native control planes, right? And that too without needing to write much code, right? So you can definitely check it out. It's pretty interesting tool. And I actually haven't worked with Crossplane yet, but I'm very looking forward to it in 2024. So these are some of the new ecosystems or separate spaces, you can say, that have developed recently in the cloud native ecosystem and which are laying the foundation of building the open standards in their respective spaces. So yeah, you can definitely check them out as well. And I'm very looking forward to seeing the developments of these particular spaces in general. Now, before I end this particular talk, I just want to cover one last topic. And I think this is something that everyone has been waiting for till now, which is why do we need these open standards, right? And to understand why, we need to understand what the impact of these open standards has been to the cloud native ecosystem, right? And the overall impact of these open standards can be summarized into three aspects, right? The number one is innovation for the vendors. So essentially, open standards define the rules and the formats on which a tool could be created, right? And they could easily integrate that tool with Kubernetes, right? If they're following these particular open standards, which we just discussed right now. So the entire focus of a particular vendor organization was shifted towards innovation, right? How can we innovate the tool more and more to solve various challenges of the end users, right? So in my opinion, open standards actually brought innovation, right? And it actually saved a lot of time for organizations, because previously a lot of time was being spent on just integrating the tools with Kubernetes, right? So now the vendor organizations could focus all of their time to innovate and create new and amazing solutions out there. The next is extensibility for the end users. Now, as I mentioned, that the vendor organizations actually focused more on innovation of the new tools. So the end users could benchmark the new tools being created just on the basis of the features that they were providing. So now for the end users, it was pretty easy to benchmark the particular tools just on the basis of the features that they were providing, right? And essentially choose the best tool out of them for their particular use case. So the open standards brought extensibility to the end users. And the last is that open standards brought interoperability for the community. So now we had multiple solutions that were solving the same problem. We had multiple networking solutions, we had multiple storage solutions, multiple service mesh solutions out there. So this basically brought interoperability within the community, right? That means we don't have to worry about being vendor lock-in and being dependent on just one single tool out there. We can choose between different tools that are solving the same challenge, and we can, select the best out of them. So that is basically, in a summarized manner, the impact of what open standards brought to the cloud native ecosystem, right? And I hope that you can genuinely see the importance of these open standards in the cloud native ecosystem. Yeah, that is it from me today. If you have any questions, feel free to reach me out on my Twitter and LinkedIn. And you can also leave a comment down below if you have any questions, or if you genuinely want to give feedback for this particular session, you can definitely comment it down below. And this is a QR code, by the way, which you can scan and get access to certain resources which I've curated related to the open standards and the recent developments that has been happening. So you can definitely check it out. You can scan this one. And lastly, I want to give a huge shout out to Michael for organizing such an amazing event, bringing all these amazing speakers and diverse topics. I hope you're enjoying the conference in general. And yeah, thank you so much for attending this particular talk.